So A is equal to 3 then?
So for this one, we write 3x squared minus 2x plus 3 over x minus 1 squared x plus 2. And now look, there's a square. So what do? A over x minus 1, but then b over x minus 1 squared.
So
right?
we don't. Oh, wait,
If this was a third power, then what do?
X minus 3.
1 cubed will be the next one, right? Yeah, and then whatever power you have, you need it. You need to go up till there.
So now we write minus 3 over x plus 2.
Plus c over x plus 2, yes.
I thought the reverse psychology.
Yes.
If I have my variables different, like if I have, like if I switch my A and B.
Okay, so the question is, what if I had these switched or something? That's fine. Yeah. At the end of the day, you get the same answer. Good. Yeah. Okay. So now let's try to solve this by multiplying this to the other side. And that will give you 3x squared minus 2x plus 3 equals to 8 times what? 8 times?
X minus 1 squared plus X.
No. One of the x minus will want to cancel when you multiply, right?
So there's
So-
X minus.
X minus 1,
X minus 1, x plus
x
2.
plus 2. Okay. Plus b times what?
X minus 1, x plus 2.
No, just X
No,
plus 2.
just x plus 2, right?
And the other one would be X minus 1
c times x minus 1
squared.
squared. Is it fine? Okay. Something's
That's
reflected.
his flash, it's his watch.
Is it? Oh,
Yeah, it
okay. That's cool. All right, so that's what we have. Now, we're free to plug in values. Right? So two sides are equal as functions. Okay, so what do we get? If we plug in 1, then this will be 3 minus 2 plus 3, which is 4. X minus 1, when you plug in 1 minus 1 is 0. 1 minus 1 is 0, so these are gone. And the only thing that you get is b times 3. So that b must be 4/3.
Oh, you plug in 1 to the actual equation?
Yeah. We're plugging in 1 because the two sides are equal as functions, so they have to be equal for any value I plug in.
How come you didn't do your shortcut?
We are doing the shortcut.
He's doing the shortcut.
Yeah, it's the shortcut, okay? All right, and then we plug in what? X equals 2? Negative 2. Yeah, you want to plug in the negative 2 because this time this is gone, and this will be negative 2 minus 1 and negative 3 squared will be 9c on the right side. Okay, that's like 4, 12 plus 4, 16 plus 3, 19. So you get 9c equals to 19, so that c is equal to 19 over 9. Okay, it's not pretty. Oh, but wait. We ran out of good numbers to plug in.
0.
Okay, so that's, actually that's what it is. Okay,
Correct.
if you run out of numbers, then plug in 0. Okay?
Really? Every time you can do that?
You
If
can
you don't
do
have
that.
anything better to do.
Yeah. I mean, 0 is relatively easy to compute, at least on the left side, right? You get 3. So if I plug in x equals to 0,
You just get 3.
you get 3 equals to negative 1 times 2 will be negative 2a. This will be 2b. And then this will be negative 1 squared, which will be positive 1c, positive c. And then since we have the value for b, which is 4/3, we have the value for c, which is 19 over 9. So we can solve this somehow, right?
I have a question.
Yes.
How come you equal 4 equal to b times 3? Where's
This
4
one?
come from? Yeah.
Oh, if you plug in 1, 3 minus 2 is 1, 1 plus 3 is 4.
Oh, so you just did it. Okay.
Yeah, I just plugged in 1 on the left side, and I plugged in 1 on the right side, and they have to be equal. Okay, I don't feel like doing this. It's disgusting. Yeah.
Yeah, me neither.
Yeah, okay, so let me show you differently. Oh, somebody's really disgusted. All right. Okay, so here's another way to think about this. And it's slightly if not, like, really, it's slightly easier. And the idea is this. You expand everything. So this will be like a times x squared plus x minus 2, bx plus 2b. And this will be c times x squared minus 2x plus 1. And you expand further, right? And so you multiply, 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 multiply. But we're already tired, right? So we don't have the energy to actually do the multiplication. So what do? We imagine ourselves doing the work. Okay? And sometimes that works. Like instead of actually doing the work, imagine yourself doing the work. Okay? So nice, right? Okay, so if you imagine yourself doing the work, I have ax squared here, and then cx squared, and I claim there's no other x squared. You get it? Right? The only x squared you're going to get is ax squared and cx squared. And by the way, you didn't really have to write this down to know that. You could just say, oh, axx, that'll be ax squared. This wouldn't create any x squared. This will be x squared, and then c will be multiplied. So you get ax squared and cx squared. So on the right side, the x squared term would be a plus c x squared. On the left side, what's the x squared term?
3x.
3x.
3x squared. So this must mean that a plus c is
C is 3.
3. It must be 3, and therefore, if you replace c by 19 over 9, which is 27 over 9, and then you subtract, you get a as 8 over 9. Okay, that's not better. Okay? So what I'm trying to show you here is that basically there are two approaches to getting these unknowns, which is one is to expand everything, organize by like terms, and then compare the coefficients. So coefficient comparison method is one. Another one is to exploit the fact that these two sides are equal as functions, therefore just plug in anything you can. And sometimes you can choose nice numbers that will make a lot of the unknowns disappear. So that's like a plugging in method. So there are two things, coefficient comparison and plugging in. Usually plugging in is easier, but sometimes you run out of nice numbers and you end up with some disgusting equation. So in that case, try to do the work, but don't actually do the work, it's too much. Just imagine yourself doing the work. And then imagine what's going to happen if you actually expand it. Look at the highest order term. So here, I call this comparing the highest order term. And that, because the highest order term is x squared and x squared here, they should match, and that gives you a simpler equation. All right, so where are we at? Now we know that 3x squared minus 2x plus 3 over x minus 1 squared, x plus 2, is equal to 8 over 9, x minus 1, plus b, where's b? 4/3. 4/3, x minus 1 squared, plus, and then 19 over 9, x plus 2, and therefore integrating this is same as integrating each one of these. And this one gives you 8 over 9, ln of absolute value x minus 1. This one, we've done a similar calculation before. So maybe this is another one that you want to memorize. Okay, so if you integrate 1 over x squared, you get negative 1 over x. So if you integrate something squared, it's going to be just negative 1 over that thing. Then plus 19 over 9, ln of absolute value of x plus 2, plus c. Okay, so that's the answer.